These motion problems, as we saw in chapter 3, the basic formula for the motion problems is rate times time equals the distance, or distance equals rate times time. The variables are sometimes used in problems like these. And let's take a look at our first example here. If you look in your textbook, you're going to have to follow along here with your book on page 308. So our problem states 2 cars start toward each other at the same time from towns 612 miles apart, and they pass in 6 hours. One travels 2 miles per hour faster than the other. How fast is each car traveling? So we've got 2 cars. We've got the faster car and the slower car. And we can state the faster car as R of F. That's your subscription, so that you can identify the faster car. And then the slower car, the rate of the slower car. So here's your rate of the faster car and then rate of the slower car. The faster car takes 6 hours. The slower car also takes 6 hours because you're trying to see when they pass in 6 hours where they will be. The faster car, the distance is going to be 6, the time, times the rate of the faster car. And then for the slower car, you have 6 times the rate of the slower car. The rate of the faster car, it says 1 travels 2 miles per hour faster. So that rate of the slower car plus 2, because this is the rate of the faster car is 2 miles per hour faster than the slower car. Now we can take our 2 distances, the distance of the faster car, which is this right here, plus the distance of the slower car, and that equals the total distance of 612 miles. When you solve for each of these here, well, the rate of the faster car, you plug this in to the R of F, and your rate of the faster car is going to be 52 miles per hour. And then because you have 50 plus 2, then the rate of the slower car is going to be 50. The slower car is traveling at 50 miles per hour, and the faster car is traveling at 52 miles per hour. When we take a look at wind and water, a headwind of X miles per hour reduces the rate of speed by X. So reduce, that means you're going to be subtracting. A tailwind of X miles per hour increases the rate of speed by X. So then with tailwind, you add that to your rate. A current of X miles per hour increases the downstream rate of speed compared to the rate in still water. So let's take, for example, let's see, for example, we have water going down a stream at X miles per hour. Well, because it's going downhill and there's a current, that's going to make it faster, isn't it? And if you compare that to water that's just standing still, sitting still, maybe in a pond, it's not going anywhere, then that's just represented by X. A current of X miles per hour decreases the upstream rate. So if your water is going upstream, okay, up, then the rate is decreased. It's got to go slower. If you think about this, this is like the roller coaster rides at Great America, where the roller coaster, if when the roller coaster is going up, it's going slower because it's going slowly, slowly going up. And then all of a sudden, like the drop zone, it's going to drop and it goes really fast when it drops.